All right, so as we continue with Chapter 5 and dealing with algebra, one of the things that in algebraic usage we have to deal with is understanding, a basic understanding of some of the properties of our numbers. Because when we are in the world, in the realm of algebra and using variables, knowing these properties of how numbers work can be useful. Now, some of the properties, and yes, I do want you to be able to apply and preferably identify the properties. So you may have to take some time to study, what happens and so on with these properties, realizing that we do use it. Now, some of them, again, like the identity property here, you are probably going to go, oh yeah, okay, I get it. Simply the identity property is this: any number plus 0 keeps its identity or its value, which basically means that I can add 0 to anything and not change the value of that number, okay? So a plus 0 is a, because we know anytime we add 0 to a number, in this case our number is a, the value of that number keeps its identity. 4 plus 0 is 4. It doesn't change. Now the identity property has two parts because we have a number in multiplication that works similarly, and that would be the number 1. Because anytime I multiply by 1, a number by 1, that number keeps its identity. So if I go a times 1, I still have a. So 5 times 1 is 5, and this is just an example. So the identity property basically tells us that we have a number in addition, 0, that when I add 0 to anything, it doesn't change the identity of that number. And the same thing in multiplication, although it happens to be 1. Okay, so that is the identity property. We also have the 0 property, and this only applies to multiplication. Anything times 0 is 0. Again, this is something that you already know. We are just putting a name to that property. And so as an example, 5 times 0 is 0. Okay, so again, some of the properties that we deal with are very simple. We're just giving them names so that as mathematicians we can speak to one another about how numbers work. Now the commutative property. First of all, the commutative property works in addition and multiplication. And the idea of commute means to move. Okay, if your parents say they work in Ann Arbor or something, and they commute to work, well, they go from Jackson to Ann Arbor to work. They are commuting. But what we're basically saying is addition can be done in any order. 8 plus 5 is the same thing as 5 plus 8. Both of them are 13. Now you'll notice here this is just a little diagram with dots. 8 dots plus 5 dots is 13 dots. 5 dots plus 8 dots is also 13 dots. It doesn't matter which order we add those things together. Multiplication works similarly. 3 times 4, and again, I'm using x for multiply. We're going to get away from that, but 3 times 4 is 12. 4 times 3 is 12. No matter how I do it, 4 columns of 3 or 3 columns of 4, I still have 12 tiles. Okay, so the commutative property of multiplication and addition, or the commutative property has two parts. One is multiplication, one is addition, and basically tells us that we can add or multiply in either order. And those are things that you know. Now you'll notice here though, I do not have subtraction. I do not have division, because commutative property does not apply to addition or division. Okay, so if we're doing the algebraic way, if you to look in a textbook, this is what you would probably see. For addition, a plus b is the same thing as b plus a. Again, 2 plus 3 is the same thing as 3 plus 2. That's just an example. If we're talking multiplication, a times b, no space, multiplication, will be the same thing as b times a. And again, I'm using 2 and 3 here as an example. 2 times 3 is the same thing as 3 times 2. Either way gives us 6. The associative property. Numbers can be regrouped, and this works for addition and multiplication. So basically what we're saying here is if I have 3 numbers added together, 8, 5, and 2, I can group them any way I want. I can do the 5 plus 2 is 7, and then add 8 to it, and that gives me 15. Or I can go 8 plus 5 first. 8 plus 5 is 13, and then plus 2 is that 17. Okay. Oh, sorry, 13. 15. Sorry, I messed it up twice. 8, that would be 13 plus 2 is 15. And you'll notice here, 8 plus 5, so I'm adding these two sets of dots together first. No, sorry, I'm not. I got that backwards. 5 plus 2, it's in parentheses, that goes first. Putting those two sets of dots together, that's 7 plus this 8 is 15. Over here, I'm doing 8 plus 5, so these two sets of dots, and then plus the 2. Either way, total of 15. Works for multiplication as well. For if I go in this, and in this case you'll notice I'm using the asterisk. This is another way that we can show multiplication. 4 times 2 is 8. 8 times 3 is 24. Or 4 times 3, doing it first, is 12, times 2 is 24. And however you want to do it, you should notice here that we end up with 24 tiles on each side. So the associative property, sometimes called the regrouping property. Same thing here, and I'm going to go ahead and I'll do this out by hand. 26 or 23 and 6 is 29. Okay, plus our 7 is 36, right? Okay. 7 and 23 is 30. Plus 6 is 36. Either way, equal. Okay. 5 times 7, 35. Times 4, and 4 times 5 is 20. Carry it 2. 4 times 3 is 12, and 2 is 14, so 140. Hopefully on this other side we'll end up with 140. 4 times 5 is 20. Now times 7, 20 times 7 is 140, and you'll notice it's equal. The solutions are equal. I just grouped the numbers differently, did them in a different order, but for multiplication and addition, it works out just fine. Okay. The algebra would go like this for addition. A plus B in parentheses, doing those first, then plus C. In the second side, B and C are grouped, then plus A. Again, here is a number example, and let's go ahead and finish this out. 2 plus 3 is 5, plus 4 is 9. And in this case, 3 plus 4 is 7. Sorry, 7 plus 2 is 9. So either way, you'll notice I ended up with the same solution. And for multiplication, A times B, then times C in the first side. Or you can go B times C, then times A in the second side. And so in this case, 2 times 3, I went back to using the x. 2 times 3 is 6, times 4 is 24 this way. In this case, so we'll have 2 times 3 times 4 is 12. And then 24, you'll notice they both work out to being 24. We then get to the distributive property, and this is multiplication over addition. And here's what, in the first case, you might ask the question, well, why do I need to know this? What is it going to be useful for? The distributive property is more useful when it comes to mental mathematics and when you have variables involved. Now, this example does not have a variable involved, but here's something that we can do, okay? If I just simplify this side using the order of operations, 5 plus 2 is 7, okay? And so times 8, 8 times 7 is 56. So using the order of operations inside the parentheses and so on gives me the 56. Now, the other way I can do this is what we can use, what we say is the distributive property, and that means in sort of to pass out or to give out evenly. What I can do is, because this is multiplication here, no space, I can take the 8 and I can distribute it through multiplication to each of the numbers inside. Let me get my little arcs here to come up. Okay. So if I want to, if I need to, it might be easier at times, I can go 5 times 8 is not 35, it's 40. You can tell I'm doing this on my summer vacation. My brain is not quite into it yet. So 8 times 5, okay? And then 8 times 2 is 16. And I can take those two parts and add them together, and you notice what I get is 56. Okay? Now again, you may not think that that's that big of a deal here. But in mental mathematics, it might be useful. And here's why, okay? 7 times 23. You may not be very good at 7 times 23, but 23 is actually 20 plus 3. And again, I'm thinking of you doing this in your head. Okay, I'm doing it out by hand so that you can see it. But you'll notice here, for most people, it is probably easier to go 7 times 20 is 140, and 7 times 3 is 21, and then I can put those together into a 161, okay? Because a lot of people aren't going to do 23 times 7 in their head. Or 6 times 14. Well, 14 is not a common thing for us, but if we were to break 14 into 10 plus 4 instead, oh, sorry, this is a 6. 6 times 10 is 60. Okay, I'm just distributing the 6. 6 times 4 is 24. Now, if I put those together, 84. Okay, 31 is 30 plus 1. And 8 times 30 is pretty simple, because 8 times 3 is 24, and I stick on the 0. And then 8 times 1 is 8, so 240 plus 8 is 248. You can do the same thing for 3-digit numbers. In this particular case, I might call this 200 plus 4. Okay, so 9 times 200, well, 9 times 2 is 18, and then tack on the 2 zeros. 9 times 4 is 36, so 1800 plus 36 is 1836. 103, 100 plus 3 times this 5, so 500. It's 5 times 100. 5 times 3 is 15, 515. 16, I'm going to go, well, I'll just go 10 plus 6. Most people are better with multiplication anyway, or addition. 5 times 10 is 50. 5 times 6 is 30. 80. And we're done. So, now, and this is where it gets a little bit more handy. Is when we're distributing, because the problem that we run into, 5 plus 4x, I can't simplify that any further. Those are of unlike terms, but I can still distribute the 8, okay? And this helps us when we're simplifying algebraic expressions. 8 times 5 is 40, okay? So 8 times 5 is 40. 8 times 4x, I can do that, because I can go 8 times 4 is 32, and then tack on my x. 8 times 4x is 32x. And that allows me to simplify the expression so that down the road I can use this a little bit further. So let's go ahead. 5 times 2 is 10. 5 times 5y is 25y. Distribute the 3. 3 times 2 is 6. 3 times 10b is 30. B, and distribute the 4. 4 times 5 is 20. Please ignore my poor writing. 4 times 5r is 20r. I'm just going to work my way back across. 6 times 8 is 48. Plus 8 times 4 is 32. 32h. 9 times 6 is 54. 9 times 7 is 63. B. 4 times 7 is 28. 7 times 6x is 42x. And yeah, this is a preliminary step to things that we're going to do further down the road when we're simplifying expressions and so on. So, all right, your turn to practice using those properties. Again, try to figure out what are their names. Come help me when you need help with applications and so on. Otherwise, go ahead and get to your practice, and I will chat with you later. Good luck.